Alright, problem 4-22 says solve the quantity of x minus 3 squared minus 2 equals x plus 1 graphically. Says, is there more than one way to do this? Explain. So I've got my graphing calculator out. You'll need yours out if you don't have it out already. And we're going to look at solving this using a couple of the methods that you should have practiced in class. So one of the first methods we used in class was we looked at taking this equation and breaking it into two functions based on our expressions that we have on either side of the equal sign. So let's take it here and let's write down what our functions are going to be. So I'm going to take the left side here. I'm going to say let's let y equal the quantity of x minus 3 squared minus 2. Then let's take the right side and let's make a second function. We're going to have y equals x plus 1. Okay, so now we have two functions here. We're trying to solve for x. We want to know what values of x are going to make this equation true. So we're going to go over here to our graphing calculator. I'm going to move it over here a little bit for you. So let's take it and let's plug in on our y equals menu here. We're going to plug in the quantity of x minus 3 squared minus 2. And I'm going to arrow down here and I'm going to put in the second function, y equals x plus 1. So by graphing these two functions, we're going to get a system that's going to appear on our graph, and we're looking for those intersection points. So our first one here was a parabola. The second one here is linear. So we ended up here, we have, it looks like, two intersection points. So to figure out exactly where, let's pull out that graph if it will cooperate. And it may not want to. Alright, we won't. We'll just go with it here. Alright, so to find our intersection points, let's go ahead and use the intersect function on the calculator. And if you don't remember how to do that, I'm going to bring it up here so you can see here. I'll just have the key press history here. All the buttons I press will show up on the side here. So we're going to start out by pressing second. We're going to go press the trace button here. So we're going to use that calculate menu. And we want to do the intersection, number 5. So go down to number 5. And now we have to mark each of the curves or the graphs here that we want to find the intersection of. So you'll notice here that our cursor is on our parabola right now. So let's just go ahead and mark it by pressing enter. And we have our cursor now jumps over to the line. We'll press enter there. We've marked those two. And it's going to find the intersection point that's closest to these 2 points that we've marked. So we press enter a third time here, and you'll see that the intersection point it gives us is x equals 1 and y equals 2 there. So our intersection that we're looking for, or the part of the coordinate, would be the x coordinate there. But I'll go ahead and write down here that our points here that we came up with, the first one is going to be the point 1, 2. But remember here, we're looking for the x values. I'm going to write up here just a separate note here, x equals 1. Remember, this is just the intersection point, but the solution that we're looking for is the x coordinate. And let's find the second one now. So when we do that here, I'm going to go ahead and clear my key press history. We're going to do this exact same thing. We're going to do second, trace, number 5 again. Now this time we want to mark our curves so that the points that we choose are a little bit closer to this intersection point. So what I'm going to do here is I'm going to go ahead and arrow over. So I'm just a little bit closer to this intersection point. Then I'm going to mark the curve right there. I'm going to press enter. And you'll see the other one jumps up and it's closer to this intersection point as well. Press enter again, and then the third time and it gives me that the intersection point is the point 6, 7. So I'm going to record that here. But remember, we're focused on the x values because the x values are what we're looking at up in our original equation here. We just turned them into functions. We brought y into this. So we know that our other part of our solution is going to be where x equals 6. Now, how can we check these? Well, let's take our values and let's plug them in to our equation to make sure it makes it true. So let's start out with 1. We're going to say here, I'm going to write here, this is going to be my check. I'm going to say 1 minus 3 squared minus 2 should equal 1 plus 1. So 1 minus 3 is going to give us negative 2. We've got negative 2 squared minus 2. Well, negative 2 squared would be 4, and 4 minus 2 should give us 2. And if we bring down our right side, 1 plus 1 should give us 2. That is correct. Now kind of notice here, when we plugged in 1 into our equation here, look at what we ended up with on each side. We got that the right side was equal to 2 and the left side was equal to 2. What was the other part of that intersection point there? The value of our y-coordinate when x was 1 was 2. That's where we get 2 for each of those. So think about when we plug in 6 here. Remember, 6 is going to be our solution if it works out, but then what would each side of our equation end up equaling? It should end up equaling 7, right? So let's check it and see if that works. I'll do this one in red so it kind of stands out. So let's do the quantity of 6 minus 3 squared minus 2 should equal 6 plus 1. 6 minus 3 is going to be 3, so we end up with 3 squared minus 2. 3 squared is 9, and 9 minus 2 definitely gives us 7. And we do 6 plus 1, that also gives us 7. So we know that this is correct because it makes a true statement. Notice there that the y-coordinate does reappear in the solution to the system. Okay? But our answers that we're looking for right now are where x equals 1 or x equals 6. That's what the solution to this equation is. Now they ask us, is there more than one way to do this and to explain? Okay. Well, I've just showed you one method that you should have practiced in class by taking the equation and breaking it into two functions. There is another method for doing this and using the calculator. There's actually several, but I'm going to focus on the graphing part of it. So let's go ahead here. Let's just shrink that a little bit there. If you were to solve this algebraically, and I'm going to go ahead here and do that just so you can see some shortcuts that I want you to see. Let's just restart here with x minus 3 squared minus 2 equals x plus 1. If I was going to solve this algebraically, I want you to make sure you remember that there. We would take this and we would multiply the two binomials here together, and we should end up with x squared minus 6x plus 9 minus 2 equals x plus 1. Well, then we would take it and we would subtract our 2 from our 9, and we'd have x squared minus 6x plus 7 equals x plus 1. Then we could undo what we've done over here by subtracting an x from each side, subtract a 1 from each side, and you have x squared minus 7x plus 6 equals 0. So we have a parabola here, right? And you know, if you were to factor this, you could go ahead and solve it the rest of the way, or you could take it and you could graph this parabola. And I want to take it and do that now. Now if we're going to type it into the calculator, remember this 0 doesn't end up being in the calculator. We're actually going to graph up the function here where we have y equals our trinomial here, x squared minus 7x plus 6. But we're going to want to look at where y is 0, or the x-intercepts, to get our solution here. Let's see if this works. Let's go x squared minus 7x plus 6. And let's graph it. Now let's go, and I'm going to move this over here. I'm going to cover some of my other work here. But I want you to see, okay, if we take this and we look at trying to find where it crosses the x-axis, there is another function you can use on the calculator to help you out with this. Let's do, let's clear our key press history. I want you to see here, we're trying to find the zeros here, or the roots, or the x-intercepts. That's all words that mean the same thing here. We've got x-intercept, we call it the zeros. It's also called the root. Okay, these are all words that mean the same thing. So what we're going to do here is there's another function under the calculate menu that we can use. Let's go to second, and let's press trace. And do any of these words appear in the menu? You'll see where we have 0 listed there. So we're going to choose number 2. Now we'll see here, they want us to mark a boundary. They want us to create a little window here that it's going to look between to find the zeros. So I need to make sure that my cursor is on the left side of whatever intercept I'm trying to find. So I'm going to find this one first. So my cursor is to the left, so I'll press enter. And then it wants us to mark a right boundary. So I'm going to arrow over a little bit here. So I'm to the right of it there. And it's hard to see, but there's a little arrow up here that marks the left boundary. When I press enter here, you'll see that there's another arrow here. So it's going to look between these two arrows to figure out where the 0 is, or the x-intercept. So we take it here and I press enter one more time, and it tells us that when y is 0, x equals 1. Okay, remember, x equals 1 was one of our solutions. Okay, in this case we wanted to figure out when y was 0, what was the x? In that case there we had 1 again, so this is another method here. So we've got the point 1, 0, and I'm sure you already know what the other one is going to be, but we know that x equals 1. And let's take it and let's do the same thing here. I'm going to clear out my key sequence history here, and we're going to do the same thing. We're going to do second, trace, number 2. And this time though, we want to mark a left boundary, but I'm going to, and as long as I'm to the left of this point, it's okay. I just don't want to make sure, I want to make sure that I'm not also to the left of this one. So that looks like a good spot. Let's press enter. And now I need to make sure my other boundary point is to the right of this intersection point. So let's arrow over. You can also enter an x value in just straight on the calculator here, but I think some people are more comfortable just arrowing over. All right, so we are to the right of that intersection point, so I'm going to press enter. So it's going to search between these two lines here for where our root, or our 0, is going to be. We press enter one more time, and you see that it says the other 0 is going to be the point 60. So that is our other value that we came up with. But remember, we're focused on the x coordinates. What's going to make this true? So we end up with x also equaling 6 again. We've already checked it earlier here. This is just a way to help you do it on the calculator. Might be a little bit quicker. Now, if you've paid attention this long here, I'm going to show you a little bit of shortcut rather than having to do all this work. There's a quicker way to do it. So if you're still interested, Okay, this is going to be, I'll just call this the shortcut here. So what we did here is we took it and we multiplied it out, and I know sometimes we make mistakes multiplying our binomials and things here, but I'm just looking for an equivalent equation to this here. So right now we had x squared minus 7x plus 6. Okay, and we said that equaled our 0 first, and then we took it and we turned it into a function. There is another way you can do it. Instead of taking it here and simplifying the whole thing, all we really ended up doing was we moved our quantity from the right side of the equation over to the left side. So if we start out here with x minus 3 squared minus 2 equals x plus 1. If I'm just looking for something that I can use to graph here, there's no sense in going through and simplifying all this to create the nice trinomial for graphing. If I take what I've got on this side, this entire thing, remember, and I just move it over to the left side of my equation, it'll be a lot faster and allow me to graph it here. So let's see what we have. We have x minus 3 squared, that quantity squared, minus 2 minus the quantity of x minus 1. And now that equals 0, right? Well, let's just take that function and graph it and see if we get the exact same thing. Take a lot less time to just take everything on the one side and subtract it over to the other. So here we go. Let's go over to our calculator. Let's go into our y equals menu here. And I'm actually going to go ahead and leave this one on here so we can see that they overlap. I'm going to take it here and I'm going to say x minus 3 squared minus 2, and then we're going to subtract the quantity. That is important that we keep everything together. So we have minus x minus 1. Take it there and we graph it, and you're going to see we're going to get the exact same equation we were supposed to. What happened? What did I do wrong? Oh, I see what I did wrong. I put a idiot. Alright, this was supposed to be a plus 1. I don't know why I turned into a minus 1. Hopefully you caught that and said, why is he doing that? Those are supposed to be plus 1s. So you see everybody makes mistakes. So let's just go back in here and let's just fix that here. Let's just go down. Let's turn that back into a plus like it's supposed to be. Let's graph it. And now everything should turn out the way it was supposed to turn out. There it is. Now I don't feel like a complete failure. Alright, so you see there that parabola, as long as you do it correctly and you don't make a mistake like I did, and you see everybody makes mistakes, but it should end up being the exact same parabola. Now, you just have to be careful when you're moving it across there. Obviously, I wasn't there, so don't follow my lead there, but make sure if you choose to use the shortcut there that you do it correctly. Alright, actually let me just go back. This was supposed to be minus an x plus 1 as well. Alright, hopefully this helps you there. Yes, there is more than one way to do it. Any of those methods would be considered correct. So our final solution there, one more time, was x equaled 1 and x equaled 6. Hopefully you understand at least one of the two ways to graph it and find your solution or the intersection points on the calculator there. Thanks for listening. If you have questions, make sure you still ask your teacher. All right, bye-bye.